Hello students and welcome to yet another video on foundation course for business statistics. In this video we are going to go through a very important measure of dispersion, and that is standard deviation. So let's understand what standard deviation is. Basically, standard deviation is the arithmetic mean of square of differences between the observations and its mean. Okay, so it is denoted by an alphabet sigma. I understand it's very difficult to understand whatever I just mentioned. So let us break it down, okay, and understand what I actually mean. So if, say, for example, there are four observations, okay, x1, x2, x3, x4, then what is x bar? X bar is nothing but arithmetic mean of these four observations, and that is calculated as sigma I is equal to 1 to 4 x I. So this is my x bar. So after that, what I am doing is I am taking each of the observation and subtracting it from its arithmetic mean, and I am squaring them, right? And then I'm adding those observations and dividing it by number of observations. So this actually gives me the arithmetic mean. This actually gives me the arithmetic mean of difference, square of difference of observation from its mean. And when I take square root of this, that is nothing but my sigma. So this is how I have formulated the formula mentioned here, and it would be better understood again when I demonstrate it through an example. So on next slide, let's go through the example. Okay, so this is my formula for standard deviation. Now suppose I have a series of numbers 12, 15, 21, 24, 18, 20, 16, and 18. So I have actually 8 numbers in a series. So my n is 8. So let us first find out what is the arithmetic mean of this series. And it is needless to say that it is summation of all the numbers divided by 8. So if I add all the above numbers, I get 144, and when I divide it by 8, I get 18.5. So this is my arithmetic mean of this series mentioned here, right? So I'm formulating a table now. I have x. So all the numbers in the series are mentioned in the table: 12, 15, 21. So there are around 8 numbers, so 8 rows. In my second column, what I'm doing is I'm taking each observation and subtracting it from the mean. My mean is 18.5. So 12 minus 18.5 is minus 6.5. 15 minus 18.5 is minus 3.5. 21 minus 18.5 is 2.5, so on and so forth. So this is my x minus x bar. So basically I am doing x minus x bar in this column. Then in next column I am squaring this column, right? So minus 6.5 into minus 6.5 is 42.5. Minus 3.5 into 3 minus 3.5 is 12.5, so on and so forth. Yeah, so I've actually populated this column. After that, what I am I expected to do is I'm expected to find out sigma x minus x bar, right? Sigma x minus x bar square. So if I total all this, that comes to be 100. Now I have to see here there is n. So I have to divide it by n. So that is 8, right? So sigma x minus x bar is 100. Sigma x minus x bar square divided by n is 100 divided by 8. That is 12.5. And afterwards, I have to find square root of 12.5. Okay, that is 3.54. So my standard deviation is 3.54. I hope you understood what we have done. So this is nothing but my square root of arithmetic mean of difference between of square of difference between each observation and its mean, and that's standard deviation. Okay, so I think with example it's pretty easy to understand. uh, let's go through another slide. So what is variance? Variance is square of standard deviation, so it is nothing but sigma square, right? So actually, what was my sigma? My sigma was square root of 1 by n sigma x minus x bar square. So if I do sigma square, this will be sigma square. This will be this particular equation square. So what happens is my square root goes away. So my variance actually is nothing but x minus x bar square, and which is nothing but, in the previous example what we have seen is it is 12.5. Correct? So 3.54 into 3.54 is nothing but 12.5. So my variance is 12.5. So you can equally say square root of variance is standard deviation. So square root of variance is equal to SD, or you can say variance is equal to SD square. Correct? So both is fine. There is another term, and we have seen this is nothing but measure for relativity. It's coefficient of variance, and coefficient of variance is calculated by dividing standard deviation with mean and multiplying it by 100. Okay, so my mean of the series in previous example was 18.5. So 3.54 divided by 18.5 multiplied by 100 gives me 19.13. And I can, since I'm multiplying it by 100, I can put percentage here. So it actually says that out of 18.5 mean, my standard deviation is 3.54. So what will it be for 100? So for 100, it is 19.13. So my coefficient of variance is 19.13%. Okay, so this is what no, we have seen. We have seen how to calculate standard deviation. We have seen how to calculate variance and also coefficient of variance. In next slide, let us quickly go through some business applications. So where would we need standard deviation, and some real-time applications. Okay, so it would help to do risk assessment for investors or traders, right? So traders would measure what are the volatility of the share prices for each or for relevant organizations they are actually trying to analyze. So higher the standard deviation, higher the risk, because standard deviation will be high only when share prices are fluctuating. Okay, it can fluctuate both ways. It can fall down or it can rise. It can consistently rise. It can consistently fall, or someday it can fall, someday it can rise. Okay, so at the end of the day, you can actually find out what, how far it has fallen or how far it has risen from the mean, and that tells me how volatile it is. So the more volatile it is, if it gets volatile on the higher side, you are likely to uh, get potential higher returns. From the quality control perspective, right? So if the product quality is giving, quality measures are giving high standard deviation, which means uh, my process to manufacture the product is not stable, or there are some issues. But if standard deviation is within the limits, then we can easily assume that the process is stable and quality which is churned out is pretty good. Similarly, we can also do sales forecasting and revenue analysis. So we can find out how fluctuations fluctuate, or what kind of fluctuations are there, okay, in monthly or quarterly sales. And based on that, the organization can get geared up for high or low sales period. We can also find out customer satisfaction uh, uh, responses. And if customer satisfaction responses are uniform across, see, if there are 50 customers from whom you are collecting the feedback, and all 50 have more or less given feedback saying that yeah, they are pretty happy with whatever services you have provided, then standard deviation would come out to be pretty low. But if standard deviation is high, somebody is saying that it's extremely good and somebody is saying that you are extremely bad, then it's a mixed signal. So there are diverse experiences that customer is having with the services or the products that you are manufacturing. Similarly, employee performance analysis can also be done. Uh, you can see what is the standard deviation in productivity and performance matrices, and based on that, somebody who is giving extremely low productivity, or if there are any outliers both on higher or lower side, reasons can be found out. And if there are outliers on the lower side, you are actually required to train the individual. And if there are outliers on the higher side, it's good for organization. The individual is capable and probably is ready to take more responsibilities. Okay, so this can be different business applications in which you can use standard deviation. With this, we actually come to the end of this video. In next video, we are going to look at more examples for standard deviation. So thank you so much, and bye for now.